period. They're stewards of their personal resources. They understand stewardship extends beyond their personal resources to the care of God's creation. And John has had this interest and has learned a lot, self-taught, learned a lot on his own, and we've had the opportunity to discuss some of what John has learned, and I think you'll find this very informative and exciting and stimulating material as we go through it today. So our goal is to be done by 10:30. That clock says 10 after 12, and I've noticed it hasn't moved the whole time I've been here. So, well, somebody can match. We have media here. We have staff photography here going on and video. So we'll monitor the staff. And maybe just take a break, after about an hour or so, and stretch and all. So I'm going to lead us in a prayer, and then we'll get started. Thank you, God, for the folks that have come out this morning to learn and to be better informed and better reminded, all of us, of the responsibility we have to be good stewards of the whole of your creation. You created us, you kind of put us in charge, and we haven't always done the best job, and we pray that we will learn today, and that we'll be more committed to be better caretakers of all that has been entrusted to our care as your people. Thank you for John, and bless him, anoint him as he leads us through a conversation this morning, and bless this time together. We pray in Jesus' name. Amen. Amen.
Thank you, Milton. And I want to thank Milton and Mel Amex, Steve Hyatt, and Dudley, who I reviewed my talk with. They gave me a lot of constructive feedback. I've incorporated a lot of in here, so it's a lot better now than it was when I first began. And if I didn't quite capture their points correctly, that's more on me than on them. But this is a subject that I didn't really pay much attention to for most of my life. It's a journey for me. So I'm going to share with you a little bit about myself and about the journey and what I found, and invite you maybe to join with me. I don't have all the answers. I've got a lot of questions, like maybe you do as well, but I'll kind of share you kind of what I've found, and then we can have a discussion about it. For those of you who don't know me, my name is John Fehlauer. My wife is Wendy. We moved to Texas with my work about 11 years ago, I think. I've been in Northern Hills about 10 years. It took us a while to find the right church, but the big sign out front helped us finally get to the right one. A little bit about my background. After 4 years in the Army, I completed a PhD in electrical engineering. So I'm not a scientist, but my PhD is in a close relative to science, electrical engineering. I worked for Bell Labs for 10 years and worked with a lot of scientists there. And then I discovered that the world cares a lot about money, not just the science. I didn't understand about that area, so I got an MBA from University of Pennsylvania's Wharton School, and worked for the rest of my career at AT&T in the network engineering side, where I led organizations that planned and built AT&T's worldwide digital network. In those experiences, I got to appreciate how science works, how scientists think, how to do their work, and also working with vendors who often give a little spin why their product is the best, and how do you discern, sometimes they're right, sometimes not. So I thought it was a good background. Retired 6 years ago, and I was talking to Milton about this, because for those of you who have retired, you realize that sometimes you know what you are retiring from, you're not sure what you're retiring to. And so I had a challenge, okay, what do I do now if I'm not going to work? And I came across this topic I thought would be easy to kind of understand of climate change, and I'll kind of get into that here. So, it works. Okay, so I'm going to share.
Technology.
I know, it's amazing. It's amazing stuff. This is the way the talk's going to run today. I'll share my journey a little bit with you, and kind of getting into also God and the creation story. What does the Bible say? What does Methodist Church say? And then climate change is the piece of this I'm going to focus on. That's how I started this journey. That's not where I've ended up. But I'll share kind of how it got here. And some questions that come up is it real? Is it really happening? And if it is happening, are we causing it, we humans? And if we are causing it, is it so bad? And if so, what can we do about it? And along the way, we'll have some questions and answers. Well, we'll have questions. We'll see if we have answers. We'll go from there. So I come from a perspective that science is awesome. And it's just, I've always loved science. In fact, I came across this past week just a comment from another scientist. This is a lady who's studying for a PhD in astrophysics. I don't know who she is exactly, or I know her name, but not who she is. But she just felt compelled to write that science is more than equations and formulas. It's the stars in the night sky, the grass crunching under your shoes, the salt and brine of the ocean, the rush of adrenaline and beat of your heart, the flash of a bird. It's wonder in the unknown, and that's what makes it beautiful. And so I think that's how a lot of scientists are like any of you, people with different personalities, different backgrounds, different hopes and ambitions. But a lot of them are just turned on by the discovery, the thrill of learning something nobody else has thought of before. While I was working, I didn't have a lot of time for stuff like creation care or climate change. I noticed that there'd be letters to the editor, to be op-ed pieces in newspapers about debating the science of climate change. And I thought, that's strange. Why would they do that? Why don't you just go ask the scientists? They don't debate quantum mechanics or plate tectonics or other things. Why are they debating this? But you have a busy life, you have work, you've got family obligations, choir practice, in my case, whatever. Things that keep you from looking into it. But when I retired, I said, okay, I'll have time now, I'll look into this. And but with my background, first I knew that there were a lot of bright people out there who've studied these areas a lot, and so I've got to be humble, and I'll keep an open mind. I had no opinion. I was agnostic to what the answer was. I was clueless, in other words. So one, I didn't realize it was a politically divisive topic. And maybe when I began it wasn't as divisive, but it has become so. I'm going to try to stay out of the politics on this, because I think it just makes the waters murky. But I made the decision to use what I call authoritative sources. In the scientific world, that means peer-reviewed literature. It has to be written down, it has to be peer-reviewed. There's nothing magic. Peer review is simply a quality control mechanism. It just says a few people have taken upon themselves to review a paper submitted for publication. They've checked the references. They've made sure it makes logical sense. It meets some bare minimum quality standards. The bar is not very high, I got to tell you. I've had some papers peer reviewed. This is not a high standard. But it just simply separates the infinite number of websites and people's opinions on who knows what, which we all have, from something which took the time to be a little more rigorous about how they approached it. And it's actually my friend Mike Estebeau pointed out that Acts 17:11 talks about this. Paul was going through an area of Greece called Berea, and he said the Bereans were very good people because they listened eagerly with an open mind what we said, but then they'd go home at night and check the scriptures to see if it was right. So they were, had an open mind, but they were a little skeptical in a good way. So the equivalent of scriptures in the science world is peer-reviewed literature. And science is also a community activity. It's a team sport. No one person sort of controls science. If some scientist has a new idea, they submit it through peer review, various conferences, and it might get accepted by the rest of the community or might not. And if the community kind of agrees that it's a good idea, then it advances science forward. So along the way, I got involved in some of the science history, which I'll get into. I also, it was clear to me throughout my professional career, but made more manifest by my study here, is you can attack ideas, but you never attack the person holding the ideas. That's the Latin phrase is ad hominem. So first of all, it's a sign of defeat in most people's minds. If you can't challenge the content of the message, go attack the messenger. And that's usually not a sign of defeat. And I don't think it's a very Christian thing to do either. That's my subtle way of saying don't throw any grapes at me. So as I looked at climate change, using this approach, I was amazed to find out that the people who are arguing that scientists, the community of scientists, said it's really happening, had solid scientific background, a basis for those comments, whereas people arguing against it did not. I thought there'd be a kind of a 50-50, 60-40, what the arguments are, like you might have in a court case. But the people arguing against it were uniformly based on opinions, not scientific peer-reviewed literature. So maybe I just picked the wrong subset. Instead of looking at the letters, maybe they didn't make a good case. So I bought books that people had for and against. I've got some literature on the side here. Some are scientific. One's even a textbook that they use in graduate school. So you can kind of look at what a science textbook says. It's actually called planetary science, not Earth science, because it works for any planet, any moon, any solar system. So that same answer. So I went to the Wall Street Journal, which is a place which often publishes, on the opinion section, articles questioning climate science. And I would enter the comment section and engage people on that, which isn't a very positive experience for those of you going to Lion's Den, kind of, because you get a lot of social media kind of pushback. But it was a little like playing speed chess. You kind of got, I used to respond by researching some topic, and a day later I respond to a person. Well, that's not how it works. You kind of give an answer right now. This is the answer, and you move on. But the same idea. The arguments were really not about the science. They use sciencey words a lot, but people are concerned about different things, and they're valid concerns. They're concerned about what does it mean if the government gets involved. Will they take over my life? What's it mean if it changes the economy? If it changes my lifestyle? Those are all valid concerns. But those are more consequences, not about the science. So after I went through this a while, I realized I'm learning a lot personally. I'm not an expert. I've gotten my questions answered. You might have different ones. But I wasn't really doing much about it. So I started trying to walk the walk, not just talk the talk. So I started getting involved in doing some things that we could afford to do. Not everybody can. Met our needs. We have a home in Maine that we summer at, and I got solar panels on the roof. Wasn't sure how it worked. For some reason I thought they wouldn't work in Maine. I don't know why. Turns out they work better in colder weather than warmer weather. I didn't know that. I have an electric car. To me, electric car is like a golf cart. They kind of a little slow. You kind of drive on the golf course looking for your ball. It's an awesome car. There's a few of you have driven in it with me. It kind of pushes you back in the seat. It's got awesome acceleration. I go home at night. I plug in the charger of the car. I go inside the house, plug in my cell phone. Same thing. I only go to the gas station to get the car washed, or to get the air pressure checked. Most people don't really care what's under the hood of their car. Yet it has this aura that somehow it's different. And so a lot of my journey was just learning that just because it's different and you've never done it before doesn't mean it's bad. Go try it. So I've been doing that. I'll get into this in the talk that despite people's knowledge about the science, which hasn't changed for decades, not a lot of progress has been made to address it. And so the political, the economic, the whatever head knocking is a stalemate in a lot of ways. And so is there a better way? And so I got led into the biblical side. What's the Bible say about this? What should we as Christians be doing about this? And that got me studying that aspect, and I learned a lot. Verses I've looked at my entire life, I saw through a different lens and saw different phrases that were always there, I just didn't pay attention to them. So that's me. So anyways, that's the journey here. So God is the architect, builder, and owner of creation. We all know that in the beginning God created the heavens and the earth. God created mankind. This is just from day 6. In his own image. this NIV version says, rule over the fish in the sea, etc. Some translations say have dominion over. And the dominion part has been viewed by some as being, you can do whatever you want. But that's not, I think if you look at the entire Bible, that's not what God expects, and I'll come back to that. Milton has pointed out here that for many verses, God says, and it was good in Genesis, in the creation story. It gets to creating humans, it was very good. Well, how good was it? And we'll come back to that also. And Psalm says, the earth is the Lord's, and everything in it, the world and all who live in it. Our role is more like a tenant, a caretaker. The Lord God took the man and put him in the Garden of Eden to work it and take care of it. This came home to me about a year and a half ago after Hurricane Harvey, and families in the Houston area were hit hard by the hurricane and the flooding after that. And a family who my daughter and my son-in-law knew from their church needed a place to stay. They're being evacuated, and they asked Wendy and me, can this person stay at our house? And I started wondering, I don't know about this. What's my house look like? We weren't there at the time. We were up in Maine. House is vacant. But yeah, I wasn't expecting people to be there that I don't know. And so I'm pondering this. And as I did, Wendy immediately said, yes, of course, they can come, which was the right answer. And I think I would have gotten there eventually. Wasn't there at the very beginning. Because that's how you'd like to be treated. If you had to be evacuated from your home, you'd like a place to stay. You don't want to be homeless. It's a very stressful time. Family was in a neighborhood behind a levee. The Brazos River was going to crest, and if it crested the levee, their house would be underwater. If it didn't crest the levee, they'd be fine. They didn't know, and they had forced evacuation. And so they stayed in our house, ended up being 13 people who I didn't know. They stayed at our house. We were the owner. They were tenants, and they took care of it. We came back. Nothing was broken. They knew the owner. They respected it. And I thought it was a good metaphor for me of how it's how you would behave if you were in somebody else's house. You took care of it, and we are in God's house. Are we His creation? How are we taking care of it? I didn't point out that back here in the creation story, I never realized that in the middle it said, "I give you every seed-bearing plant and every tree that has seed in it, and that's your food." I'm thinking, well, where's the beef? And luckily, the Noah covenant said actually it was between God, man, and all living creatures. I didn't realize that. I always thought, Noah promised the humans that would never send another flood again to wipe out the earth. But he also included all living creatures in it. And he gave us animals for food, so there's the beef. So, so kind of what's our role? This is my view. Humans, we can feel and think. We certainly are curious. We have lots of questions. When I retired from ATT, my boss at the time said, John asks lots of questions. They're annoying questions, but they're good questions. So I'll take good, even though they might be annoying. We also have the ability to make choices. Going back to the Adam and Eve story, you can make choices, good or bad, and choices have consequences. How we respond to what we know is our choice. I came across this in this journey that they talk about the Bible. Some theologians say the Bible is the first book of God, the inspired word of God, but His creation is another book. He's written the second book. The majesty of His creation is in front of us, all around us, and we can see Him in that creation. It's like a second book. Science is just a translation, putting into human terms things that what's going on. He's given us this puzzle that we will never fully solve. It's a never-ending puzzle. So I found that comforting. So how good is it? This is a picture of a satellite of the Earth, sometimes called the big blue dot. You can see North America's clouds, and I'm an engineer, so I never really studied this part of science. I guess I did, but didn't pay attention to too much back then in college. But I looked at it now, it's amazing. So think about it, it's the only planet in our solar system that has this much water on it. It's blue. All the others are kind of dull, Mars kind of reddish dust, and Venus is full of clouds. And, Jupiter does have a big spot, like a wart on it, a big storm, and Saturn does have rings, but they're not as pretty as this one. And I'm a biased view, I admit. But then as an engineer, you look at it and say, well, it turns out that the oceans put a lot of inertia. Scientists have looked at other planets, like the moon, for example. When it goes from sunlight, it's very hot on the surface. It goes in the shade, it gets very cold almost immediately, very quickly. The Earth rocks are a very poor conductor of heat, and it's hot or it's cold very quickly. The ocean keeps it more even keeled. So those of you who are hot in San Antonio, you go down to San Padre Island, and it's cooled by the ocean, because the ocean water tends to be cooler than the land in the summertime. In the wintertime up in Maine, where we are, along the coast of Maine, it moderates. The ocean stays warmer, and land gets cold really fast inland, but along the coast it's usually warmer than inland. So it acts like this big kind of a flywheel, if you will, a thermodynamic flywheel. It also is an amazing irrigation system. Think about it. Where does the rain come from? Well, evaporation, mostly from the ocean, could be lakes and rivers and land, but and it goes up in the air and it goes over land and comes down as rain or as snow. Ocean water is salty, but the salt doesn't go with it. So it's an irrigation system and a water purification system. Isn't it amazing? If God, I woke up one morning, a different universe, and I'm in heaven, and God says, Fehlauer, your job is to build me a universe. I wouldn't come up with this. I'd be having plumbing, have pipes, I'd have kind of, where do you plug it in? It's amazing. And ocean provides transportation. That's why a lot of cities are built along coasts and rivers, because it's easy to get around. You have to hack through bushes and trees and hills and whatnot. Provides food, but also you can't see in those pictures, there's a thin layer of gases, the atmosphere around it. 98%, 99% is made up of nitrogen and oxygen. Oxygen we need to breathe as animals. It's also used for fire. We need fire for combustion. But net 1 or 2% is amazing things happen. It's trace gases. A lot of that, about 1% up to is water vapor. That's that irrigation system. But the other things are things like what we now call greenhouse gases, things that let visible light go through, but infrared doesn't go through. It gets absorbed. It's like a blanket. The term greenhouse came up over 100 years ago because that was the way they thought about it. But you might think of it as a blanket of greenhouse gases, like carbon dioxide. It keeps our Earth about 59 degrees warmer than it otherwise would have been. If that little trace amount of greenhouse gas wasn't there, we'd be an icy cold rock, like other planets in our solar system. So it's amazing. It also has ozone, which keeps ultraviolet rays from coming and harming us, and especially people who are a little thin on top, we can need some help for that kind of stuff. So it's just an amazing process. And you can go on and on. I won't go more into science, but I'd say it is very good. As I went through here, though, the question is, well, how are we doing? Is our care of God's creation very good also? And there are signs that we do some things very well, but some things not so well. And so as I looked through different literature, some reflections came up. These are verses, these are themes that are throughout the Bible in different ways. These are ones that I'm familiar with. You might have yours. Love your neighbor as yourself, and the question Jesus was asked, well, who is my neighbor? Well, obviously we know about people here in our neighborhood, and our town, our state, our planet, but we tend to think about people living today. What about my great-great-grandchildren who don't exist yet? Are they my neighbor also? We look back at our founding fathers of our country. They lived 300 or 400 years ago, and we thank them for what they did for us. 300 or 400 years from now, will my descendants be thanking us for what we did in our time here? Good question. And then Jesus was talking, and Matthew says, the king will reply, truly I tell you, whatever you did for the least of these, my brothers and sisters of mine, you did for me. And there's a lot of justice-related themes in the creation care. You know, the people, we're a wealthy country. People like me are well-to-do compared to many others. I wouldn't say I'm wealthy, but compared to many people, I sure am. And so, you know, what am I doing for those who are less able to take care of themselves? The elderly, children, sick, people homeless, in our country, in our town, in other parts of the world. From everyone who has been given much, much will be demanded. We have a lot. We have a lot of responsibility because we've been given a lot. For where your treasure is, there your heart will be also. Well, this is a challenging one for me. I like playing golf. You know, I don't play on Sunday mornings, but you know, it's a lot of things. Whatever you pick, your hobby, pick a something you do, and the question is, you know, is that more important than what God's giving us? And so I know I struggle with that one. And Micah says, and what does the Lord require of you? To act justly. So it's justice and also action. To love mercy, and to walk humbly. The word humble comes up a lot. You know, so advanced degrees are interesting, but what have you done for me lately? It's kind of the phrase here. So some reflections. So what's the Methodist Church say about this? And I came across this, I got this from Dudley. Well read, I could tell, dog-eared pages from Dudley's book. Book of Resolutions. How many here have read the Book of Resolutions of Methodist Church? Milton, Dudley?
Mine's about the same shape as Dudley's.
Looks brand new.
It's an interesting book. It's a collection of resolutions on a variety of topics that gets passed by General Assembly. It's not mandatory, and you can debate these, and different churches are free to interpret different ones. It's like a reference book. So if you wonder how Milton gives his sermons, besides watching Kentucky basketball, he also, I'm sure, reads this and says, what does the church say about the topic? And it has Bible verses in here and a way of thinking about it. And it has some that relate to creation care, caring for creation. It has some that they're overlapping: energy policy, protection of water, environmental health. And the themes are kind of written by different people, different churches, different conferences. We often have very overlapping themes of justice and caring for creation. I picked out two here. They go by numbers. Caring for creation, a call to stewardship and justice. And so our goal is to steward, protect, and defend God's creation. And there was an example from John Wesley, which I found interesting. He preached on take care of God's creation. So he talked about how the early Methodists in England were dealing with environmental concerns. Open sewers, impure water, unplanned cities, smoke-filled air. In response to the squalor and filth in the mines and mills, Methodists advocated for a wider knowledge of concepts of basic health. They didn't know. They said, this isn't healthy, but we will do something about it. The substantial decline in the death rate in England from 1700 to 1801 can be traced to this work. So Methodists were active, and we take things for granted. Of course, you don't have open sewers. Of course, you don't kind of have clean water. Well, back then they didn't know about germs and diseases and a lot of stuff. It was a learning process, and I'm sure a lot of debate over, you know, why should we do this and why not. And so I found it interesting that he was active in that regard. On the creation care, the article, the resolution does support what I'll cover in terms of the science, what the scientific community says about climate change. Through a lot of areas of creation care, some of you might be interested in other topics in climate change. You might be interested in plastics or pure or clean water. There's a lot of ways you can approach this, and climate change is not the only one, but it's an important one, and that's why I'm going to focusing on that aspect of it. And it talks about a study, a pastoral letter from the Council of Bishops, which is here. The letter talks about 3 interrelated threats: poverty and disease, environmental degradation, climate change, and violence and weapons. And they're all interrelated because you can have poverty and disease not due to climate change, but climate change can make it worse. You have violence without poverty, but oftentimes they go hand in hand. And so there's a lot of overlap in the approach here, and they talk as interrelated. And what they called for, which is how I kind of structured the rest of my talk, is awareness. A meeting like this is awareness. Study. I've studied, and I gave you sort of my approach to how to go to authoritative sources. I am not one. I'm not a scientist. But I can point you to the authoritative sources on what I looked at. And I have some books here that do that, and you're welcome to look at them. Action. Sometimes these problems, in the expression and a lot of my professional, you have these huge problems that face you. It's like solving world hunger is sort of what people say, meaning you'll never solve it, it's just too big. And that can be paralyzing. But the message here is no, hope. We can take action, we can make a difference, and we are called to do that. Action birthed in hope rather than fear. And also a deeper spiritual consciousness as stewards and caretakers of creation. I know a lot of verses, as I mentioned, didn't see the creation care dimension of that as much as I should have. Over my life, like many of you, I didn't litter much. It's true, back when I was on the farm and I changed oil in my car, I did dump it in the backyard. I didn't know any better, I wouldn't do it now. And so, as I get older, I'm a little more responsible, and I'm learning more about it. And some things, it's not clear what the right thing to do is. We try to recycle. Is that helping? I don't know. We try to do it. We hope that it does help. And it's a lot of things that you do that I could learn from. So this is not something where I have answers to how all this stuff goes together. So let me kind of go into the climate change part of this. Okay, so climate change. I discovered, as most of you now know, it's a very politically divisive topic. It's across the political spectrum, lots of stuff gets said which I don't find as being scientifically rigorous. So I'm not picking any sides. In fact, I've consciously tried not to associate with different political parties because it tends to make you want to root for your team. And I find that there's good ideas everywhere. And what I'll be talking about here in terms of solutions, it's not people who could be on the far left or the far right or the middle could all support that. There's different ways of doing it. Same goal. I think we all share the same values. We like clean air, clean water. We like to have a good environment to live in. How we go about doing that is now a political choice, and many ways of doing that. Climate change is not just whatever you think it means. It's a statistically significant change in some climate parameter. Temperature is often mentioned. They talk about global warming, they're referring just to the climate parameter of temperature. It also could be sea level rise, that's a change in climate, or precipitation, or wind patterns. Those are not temperature terms. So climate change is just a broader way of describing that. Global warming is a narrower term. And things that occur over several decades. So it's not like we had a hot summer, therefore global warming, or we had a exceptionally cold winter, therefore global warming stopped. And it's over a period of time. So the questions here are, is it really happening? And I went through this before, so you kind of get the gist. So along the way, I kind of got into the history a little bit of, I naively thought that climate change is kind of a recent thing. It's kind of what we just, the last decade or so. Well, the first person who talked about the atmosphere and how it warms the earth, 1824. For those of you who are electrically oriented, Jean Fourier is the same person who developed Fourier transforms, the Fourier series. A lot of things that electrical engineers use all the time. He was a brilliant mathematician, a brilliant scientist, just basically thermodynamics. 1824, he established how the earth and the atmosphere relate to each other. And what are those trace gases that do? It's almost like magical. There's amazing trace gases that make a difference a lady called Eunice Foote and an Irishman called John Tyndall identified them as carbon dioxide, water vapor, methane, and some others. 1850s, 1860s. The first scientist to make a projection. If you burn enough fossil fuels, you can change the climate. 1890s, Svante Arrhenius, a Swedish Nobel Prize winner, spent a year, he went through a divorce, spent a year doing pencil and paper calculations to come up with this projection. I guess his way of working through the pain of the divorce. But back then, people didn't think about, well, he thought it'd take thousands of years to burn the fossil fuels. And besides, what's a few degrees warmer? How bad can it be? I'm from Sweden. I like warm. So these were kind of put on the back burner, and so I looked at for a long time. In 1859, scientists called Charles Keeling said, you know, we ought to measure this. It was kind of in the coming out of World War II and the Cold War, and people were looking at a lot of military interests and what goes on. Can we control weather? And a lot of questions like that had a military component, or just basic science. And he started measuring atmospheric CO2, which is hard to do because it changes so much locally. Inside buildings, inside cities. I went to a mountaintop in Hawaii that was kind of divorced from that, and I'll show you a curve of that. Different curves, different messages resonate with different people. That was one that resonated with me. The first president to be told that this is an issue was President Johnson, 1965. He made a speech to Congress. This is something we have to worry about. 1965. Burning fossil fuels can cause global warming. The science progressed a lot, and this is kind of a techie one, just to say, but by 1967, the science was pretty much complete. Had better sensors, better quantum mechanics plays a role, relativity plays a role. A lot of very complex stuff. I've got a textbook over here that gives you that, and also a book called The Warming Papers, which is a collection of the seminal works over the last 200 years that led science forward, sometimes with mistakes, that people made poor assumptions. Fourier thought that space had heat to it, thought it was warm out there. He didn't know, there's no way of him knowing differently. So some things were good, some things were bad, but that's how science works. 1979, National Academy of Sciences was given the task of looking into this. People say it's an issue, it's really an issue, and they said, yes it is, 1979. In 1988, UN Environmental Program combined with the World Meteorological Organization formed what's called the IPCC, Intergovernmental Panel on Climate Change. 1997 was, so it went from sort of scientific things to now sort of political things. Yes, it's an issue, what do we do about it? And that's Paris Accord. And the answer is, we haven't made a lot of progress. So we're still at the starting gates in this in some ways. So this is one chart that made sense to me. I have a series of charts, as a matter of fact, let me pass these out. Dudley said it might be hard to see these from the back, so he said, I'll make some copies so you can pass these around. I've got 20 copies, so maybe share if you're next to somebody who does pass them around. Just so this is the global surface temperature. This is average across the globe, so it's not just San Antonio. Again, 70% of the globe is water, so it's not cities. It's also the ocean. And you can see it varies a lot up and down by year. That's the blue curve. That's like weather related, El Nino, other events like that. But then you look at the trend, and the trend is going up. Don't need a sophisticated computer model to say it's getting warmer. That's what the numbers show. This is data from, I think this comes from NASA. There are 4 major organizations in the world who do this kind of stuff. There's NASA, there's NOAA, there's the British Met Office, and the Japanese. And they process data a little differently, they make little different assumptions. It's the same message along the way. Another way of measuring, I have it in the backup, I'm not going to go through all of it, but you can also measure sort of heat content. It's a little more engineering or sciencey. It's measured in joules. not the ones you buy at the jewelry store. It's Joule. It's a measure of energy. 1 joule is about an apple raised 1 meter. It takes 1 joule of energy. So it's not a lot of energy. And people use joules measuring in firing weapons in the military, how many joules of energy, or other things that you can do. And they look at how much heat is being retained, and it's in the sextillions, about 250 sextillion. A sextillion is a billion trillion. Big number. And don't relate to that. So one thing that they do, well, we have to find something, raising apples, you know, a billion trillion apples 1 meter doesn't really help either to convey it. So you have to find something large enough to relate, and so one measure is the atomic bomb we dropped in Hiroshima was a lot of joules of energy. And the rate we're accumulating this is at least 5 of those bombs going off every second, every day of the year. Big world, big ocean, takes a lot to heat it up, but at some point you're going to notice that amount of energy being conveyed here. A different way of measuring it. I should point out here that along the way, El Ninos appeared on the right here, and they picked out a couple of them. The one that's here is 1998, and you might have heard that global warming stopped for 10 years or so. That was mocked in the press. Well, if you ignore everything to the left, and you start looking at the data from that peak, well, everything to the right for a lot of years is the same or less. So you say, well, it's not getting warmer. Warming has stopped. There's no scientific basis for why this extra blanket stopped warming. And it's not statistically significant, because if you look at the 1997 or 1999, you'd see an upward trend. But if you want to make some spin, you'd say, well, I'll pick the high point at the start of my interval, and now it's lower after that. Obviously, it has continued warming since then, and the heat retention figure in the back conveys it also. So this kind of goes about 1.4 degrees from the lowest point here, back in the teens, up to 1.2, so about 1.4 degrees Celsius over the last 140 years. Over a longer period of time, this is now a much narrower scale. It's only like 0.4 degrees up and down. This is coming out of the last, we call them ice ages, the last period of glaciation. It was fairly flat and actually started trending down. It was getting a little cooler on average, as best as we can tell. Didn't have thermometers back then. We had, you might call God thermometers. Scientists look at different evidence in paleontology and in paleoclimate studies to look at different animals, different fossils, different ocean sediments, and what do they tell us about the environment. And there's some uncertainty about it, but what's clear now is that yes, climate changes all the time, but changes kind of slowly, and it's going pretty fast right now. I put some things down here. Up until about 10, 12,000 years ago, we were mostly hunter-gatherers as a species. Around 10,000, it varied by part of the world. You can tell, probably around then, we started getting involved in agriculture, which means you clear the land, you take care of plants, and then you want to eat the benefits of what you sowed, so you're going to have to defend it. So you have to get some king to kind of watch over your neighborhood, and a little army to make sure you can defend it. And that's civilization. People start getting more fixed. They weren't hunter-gatherers. The population back here was probably in the, I don't know, a few million, 10 million people. Again, no census back then, but you really could tell a number of hunter-gatherer tribes around the world, probably in that range of low double-digit millions of people. Jericho was founded around here. Jericho is one of the oldest cities in continuous use in the world, about 10,000, 8,000, 10,000 BC. Looking over here, Solomon's temple, Solomon built it around 3,000 years ago, about 1,000 BC. And Jesus, 2,000 years ago. And so the climate has been fairly stable over that period of time. It didn't really change a lot. Our civilization, in other words, was built assuming climate's not changing. Or if it does change, it changes very slowly. At Jesus' time, it was about a few 100 million people, maybe, on the planet back then. And actually, if it did change, it wasn't a big deal. So you picture here in the United States, if you're in the Dutch in Manhattan a few hundred years ago, and the sea levels rise, well, you just move someplace else. Not a big deal. It's no big infrastructure. You don't have huge cities and military bases and built along coastlines. So our civilization, climate change is not, scientists aren't saying it's going to kill the human race. We're saying our civilization will be damaged. And is that a catastrophe or not? That's now a subjective decision, but it's not one that we ought to go into lightly.
Sean, before you change from that slide, what are the gray spiky parts at the
Yeah,
end there?
yeah.
Obviously more data that we,
Yeah, so they had, they're different, actually overlaying several different, I try to get pictures I didn't have to make myself, and this is one of the ones I wanted to cover this. They used one technique, a scientist called Marcotte, published in the Science magazine, had this part, and they overlaid some other things. There's a project called the Pages 2K that has been focusing on the last 2,000 years and collecting data for that, and that's what the squiggles here are. And so that the absolute numbers aren't as important as more the trend lines. And it's that previous chart I showed, this kind of gradually looking curve. When you look at it more from God's perspective, a geological perspective, over 1,000 years, it's going vertical, because that's happening in a 100-year kind of interval.
thank you.
So, what's causing this? Well, this just like if you put on a sheet at night when you go to bed, or a long sleeve shirt, it warms you. But if you're still cold, you put on a jacket on top, you put on a thicker blanket. And we're adding another blanket, if you will, to the layer in their atmosphere. And this was a measurement of CO2 that Charles Keeling started making in 1959. The very regular up and down here, it's amazing. Almost like Earth is breathing. This is actually seasons. Plants take in CO2 and put out oxygen. And animals breathe in oxygen and put out CO2. It's been in balance for millennia, for thousands of years, hundreds of thousands of years. But we're now changing that. We're tipping the scales. We're adding more to it. So this up and down is, it goes up when plants die, leaves fall off trees. Most of the land is northern hemisphere, and it's the season in the northern hemisphere. And then when plants grow in the spring, they put out new leaves, they put up new shoots, they grow, the CO2 level goes down. It's a very regular up and down. That's just seasonal changes. Amazing. But the trend is upward, and it's like CO2 is like a control knob on the climate. I have it in the backup. I'm not going to show a slide here, but you can look in the backup. There's a slide that says we can go back looking at air bubbles in ice cores from Antarctica. It goes back 800,000 years. It's amazing to be a scientist and kind of melt this ice, and the air that comes out was 800,000 years ago. Homo sapiens, our humans, have only been around 200,000, 300,000 years. It's in that range. So it's this level of carbon dioxide is higher than humans have ever experienced. This was not the environment God gave us. It never got above 300. This is in parts per million. Again, it's not a lot of gas, but it doesn't take a lot. It's higher than it's ever been, and it's getting higher. Scientists look at what is adding the CO2. Could it be from volcanoes? Could it be from outgassing from tectonic plates moving? The answer is no. They look at it from a couple of different ways. They look at how much fossil fuels are burning, and you burn something, you put out CO2, among other things, and how much is that being put out, and it's more than enough to explain this. The rest goes into the ocean, which is good. It also makes the ocean acidic, but also it's they look at the isotopes of the CO2 and tell it's coming from burning fossil fuels. Or you had a question?
Well, I was just wondering, in your research, did you find anything about as far as deforestation or the, our natural regulatory cycle with the plants? How does that factor in as far as?
Yeah,
changing
they call it land use changes, and that's the problem. People are in Indonesia and the Amazon rainforest taking down a lot of trees, and trees are plants are a big factor in absorbing excess CO2, and the fewer we have, the less absorbing you're going to have, and the more it goes up into the atmosphere. And so one of the things that people are looking at is, should we plant more trees? Can we make an artificial tree kind of thing that takes in CO2 from the air and puts out oxygen? There's, I think the Canadians, the Chinese plant billions of trees trying to kind of make the air better. I've not studied exactly how practical those ideas are, but it's one that's been looked at.
Yeah, I was just, as a corollary, just wondering, as far as the type of trees, is it like deciduous trees, would that not be as effective as, say, evergreens, or that don't lose leaves?
I don't know.
Oh.
Yeah, I don't know. Good question. Jerry?
Well, Mauna Loa has no trees.
Right.
It's,
Yeah.
And it's on the Big Island where where the volcanoes
Yeah,
are.
yeah.
So that's gotta be questionable, I think.
Well, he picked it because there are no trees there. He wanted to, because that would color the measurements. CO2 is what they call a well-mixed gas. So you get a lot of local change. Methane might be a little more local. Some, like a pollen, very localized. The scent of honeysuckle, if you're from the south, or magnolia trees, very localized. It doesn't go very far. You want to get measurement. What's the overall atmosphere? You look at Antarctica and Mauna Loa. There was, in fact, in the somewhere in the 1980s, Mauna Loa had an eruption, but you can't tell where it is in the chart because it had no particular effect. Volcanoes erupt in different ways, and sometimes they put out more CO2 and sometimes not. But it's not had, in general, volcanoes are a fraction of a percent of what people put out. We're over 7 billion people now, and a lot of people, and it puts out a lot of CO2. I'll come to that. As an engineer, if somebody says, well, Fehlauer, this curve is heading the wrong direction, flatten it out. The first thing I'd like to look at before I saw the graph is, well, show me where we had it flat before, and I'll figure out what we did then, and we'll just do more of that. That's how engineers think about this kind of stuff. Well, there is no place I could look at that we did something. Not only is it never flatten out, it's going up, as you see, at a steeper and steeper rate. It's accelerating in the wrong direction. So this is a chart that I put together. Color choice was mine. Mr. USA was blue, but this kind of shows the burning. This GT is a gigaton. A gigaton is 1 billion tons. And as far as we talk about industrial revolution, but really wasn't a whole lot until about I'd say about 1950. A couple things happened. Post-war boom, and Milton and I were born.
Oh, you're causing it then.
Just saying.
Just saying.
That's called correlation, it's not causation. But I didn't realize it lingers in the air for centuries. Some of the CO2 we put up there, about 10 or 20%, might stay there for millennia. We've changed God's design. We've put more CO2 than we've ever had before. And you kind of see, it's the area, how much blue is there. The USA, America, has 4 to 5% of the world's population, and we put up 20 to 25% of the CO2 that's up there. So we are, it's like we got to the cookie jar first and got a lot of cookies. Fossil fuels have done great things for our society. I'm not bashing fossil fuels. We have a tremendous economy. We had tremendous advances in health and medicine, in technology. So it's done wonderful things for us. But now we know there's a downside to it. All technologies have a downside. There's no perfect thing we've invented that is ideal for everything. But now we know more about the downside of fossil fuels. I personally don't really care how the electricity gets generated that comes in my house. Whether it's from one plant or another, as long as it works. Well, now I do care. I prefer it to be something that doesn't increase this, but that's not exactly my job. I can't control that. We'll come back to that. So you kind of see the growth here. These are European Union countries, and the USA is coming down a little bit. EU, China is growing. They were small back here until the 1980s. They started growing a lot. India's starting to get bigger now, but most of the world, they add very little. So the ones that are, and they're going to suffer the most. They don't have the resilience to handle climate change. And so part of the debate, again, I don't have an answer for this, but a question to ask ourselves: what's fair? What's just? Should we keep on living our lifestyle if other people suffer? There's been some news in the past few months about we have 12 years to change this. Well, that's not exactly what was said by the scientists. What they're saying was we had made a commitment, we being human race, in Paris, saying let's try to keep the warming at 1.5 degrees centigrade. And well, if the CO2 controls temperature and if it stays there forever, how much left do we have? What's our budget? There isn't a whole lot left. And there was a goal, you'd have to cut by 50% by 2030. But there's no cliff coming. It just means that we'll miss the 1.5 degrees centigrade target. It's not like the end of the world for us, we don't think. But for those of you who've worked in business or made New Year's resolutions for dieting, if you had 12 months, I should say, to lose 12 pounds, back in January, you said, I can do that. It's just a pound a month. How hard can this be? You're like me, you procrastinate. Now it's June. That's just 2 pounds a month for 6 months. I can do that. Now it's December. I got to lose 12 pounds. The very last slide in your handout shows what could have happened if we started as a global community tailing off the emissions back in the 1990s. It would be a gradual curve. It's like starting the diet in January. But if you wait longer and longer, you run out of runway. You don't have enough time you have to have draconian kinds of measures, and that would also cause suffering if you start changing the economy in radical ways. So I didn't realize that there's no good way for CO2 to come out of the air except being absorbed by oceans, water, or by plants. Over a long period of time, weathering, creating limestone, that takes thousands of years. Yes?
With that last chart you had up there, it looks good for Europe and us, but isn't our nuclear testing affect part of the third world countries that don't have the assets to help control themselves? Does that skew it? The nuclear testing of, you said bombs going off every second.
Oh yeah, that was just
there's factors in there. It looks like, we look good, but we are affecting other parts of the world.
The bomb, have been best. What I was trying to say was, I'm trying to find something that was a big amount of energy. If it happens in a very short period of time, it's an explosion. If it happens a little slower, it's just heat. And so the amount of heat that was in a nuclear explosion. But the nuclear testing has had no effect on this. In fact, there was a debate decades ago, if you had nuclear war, thankfully we haven't had to test this theory, would there be enough particles to go in the air that will cause it to cool? Would there be a nuclear winter? And I think the belief is probably not, but we'd have bigger problems to worry about if we had a nuclear war. The testing has not had an effect. It was an issue back in the 1970s. I guess it was this, made some, Newsweek had some magazines about the coming freeze or something, the global freeze or something. There was a debate will the warming effects of greenhouse gases be dominated by the smog we put in the air? The smog particulates tends to reflect sunlight, keeps them hitting the ground. You know, it's kind of murky if you're a person trying to walk through Los Angeles or Beijing, but it keeps the sunlight hitting the ground. And the answer was, no, we don't think there'll be enough particulates there because we want to clean up for other reasons. These are very interrelated issues. Is it a problem? Yes. These are just, you read literature, these are things that come up. I'll mention a few things, and I'll highlight one which I found interesting was not as well publicized. Climate change doesn't make a hurricane. It can make it more intense. There's no evidence that will make more of them. It could, but you know, it takes a lot of years to get it statistically significant. Is it just a random coincidence we had a few in a row, or is there some trend to that? Don't know. Heat waves do kill people. Europe had one in 2003. 2010, Russia had the big one. So we had Pakistan, India had some in 2015. And so you know, looking at, as it gets more intense, not just the temperature, also humidity. Those of you who've been in Phoenix, San Antonio, Houston, you know, you get to Houston, 90 degrees of high humidity, you just get drained. You know, same temperature with low humidity is fine. So warm air holds more moisture than cool air, just physics. And so as the temperature rises, there's more water in the atmosphere. It's another greenhouse gas. It also makes it more uncomfortable. And I saw an article in the paper here a week or so ago, San Antonio Express News, the thousands of public housing units that don't have air conditioning. Homeless people don't have air conditioning. A lot of poor people don't have air conditioning. Fields that grow our crops and animals, they're not air conditioned. And so warmer temperatures create problems. More intense rainfall events. Sometimes the term weird, it makes it weird. It's not like this general, everything is warming exactly together in the uniform, steady. You get ups and downs. You see these weather maps, these polar vortexes, they're kind of spinning more wildly, all of a sudden dips down and you get really cold weather. There are ocean currents play a role. There's something that the Gulf Stream is part of a larger system of currents in the Atlantic that carries heat from the south up to the North Atlantic on the surface, and it goes down, and it takes hundreds of years to kind of go back to the south. It's amazing. It's slowing down. It's 20% slower than it had been. Why is that? Well, they got some ideas. It seems to be that melting of Greenland ice and Arctic ice, it's fresh water going into the ocean. Fresh water has a different density, less salty than the salt water. It's changing the flow. That could make Europe colder. That's strange. How do you get global warming but you get colder Europe? Well, maybe not as much heat coming up. It also makes sea level rise higher on the eastern coast because the water is not rushing up as much as staying behind. It has an effect on sea level changes. Jerry, you had a question?
Yeah, I got into discussion with my daughter-in-law's husband, was a professor at A&M, and the guy that you got listed here, he said he used to talk to him.
Okay.
And I always thought that the Atlantic conveyor went north and south. He says, no, it goes to Europe.
Yeah.
Because of the rotation of the Earth.
Okay. Yeah, they call it
What's true? I don't know.
Yeah, they call it the Atlantic Meridional Overturning Current. I had looked that one up before I got here this morning. AMOC. The Gulf Stream is one of them. There's a whole bunch of currents. Something out North Sea.
The Gulf stuff goes straight across.
Well, kind of northeast. It goes up to Ireland.
The stuff that starts at the equator, he says it doesn't go north. It goes towards Europe.
It's kind of, the pictures I saw is kind of like northeast. I know some swirls around Nova Scotia, Cape Breton to Prince Edward Island. And the Gulf of Maine gets missed, so those of you who've been up to Maine, it gets very cold there. Prince Edward Island has warmer ocean water because the Gulf Stream,
Well, the other thing he said is that's how the Vikings got to North America, on that current.
Could be. So I won't go through all these, but you get the idea. Rising sea levels is obviously a challenge. It's rising for two reasons. One is land ice is melting. The amount of ice stored in Greenland could raise, I don't know, 20 meters. Antarctica, 10 times as much. It takes a long time to melt ice. Predicting how fast ice melts is a challenge. Scientists, it won't stop at 2100. We also talk about how high will the ocean be in 2100. Well, 3 feet maybe higher, could be more, could be less. But it'll keep on melting, keep on rising. Partly it's the more water going in, and partly warm water takes up more room than cold water. So it's both the expansion of the ocean waters and the melting ice. One way to look at it is, what happened the last time we had this much CO2? About 3 to 4 million years ago, the mid-Pliocene, I guess they called it. And as near as we can tell, it was probably about 20 meters higher. Again, takes a long time. If it rises slowly, you have time to adapt. You kind of gradually, pull back from. Miami might decide that they're raising roads and doing things, but at some point they might say, not worth spending more money. Let's move someplace else. If it's over generations, it's not as bad. If it happens faster, it's an issue. The speed is the issue as much as the level. I mentioned the CO2 going into water makes carbonic acid, and things that like a less acidic water don't do as well. I'm thinking oysters, clams, lobsters. I'm thinking, health issues, vector-borne diseases. I never heard of Zika virus till recently. They moved north. I got Lyme's disease a year and a half ago up in Maine. Tick-borne diseases, increased wildfires. A lot of money. The EPA put out a document recently that said at the current rate, we will be spending hundreds of billions of dollars a year on things like climate change, recovery, disaster recovery, adaptation, and then climate refugees. Again, back 1,000 years ago, we didn't have borders, we didn't have a whole lot of people migrating and passports and photo IDs and that kind of stuff. Now, with 7 billion people, you need a little more control. You can't have people just wandering around, so we have this political structure of boundaries that didn't used to exist, but then people get cranky when somebody wants to come in. So, 7 billion people, picture 1%. That's not a big number. 1% have to move. That's 70 million people. Where do you put them? And so think about, what that means to, again, these are tough issues. There's no simple answer to them. It'd be best if people could stay where they are and live where they are. But in Central America, for us, they have a problem with crops fail due to drought, fungus in the coffee plants, etc. And if you can't eat, what are you going to do? You're going to go someplace. India, Pakistan, tremendous amount of heat. There's a cyclone hitting India as we speak. If they get fed up and just want to go someplace, you go north. Who's the north? Russia. Now you got people getting cranky with nuclear weapons. So that's why the U.S. military views it as a strategic threat, not just a threat to military bases. Carlton Hendricks is working on fixing Tyndall Air Force Base from the last hurricane, a few $1 billion. He's not working on Offutt yet, outside Omaha. It's a few billion from flooding up there. I just read this morning that Davenport, Iowa hit record levels, and the water is still rising in Mississippi. Climate change just loads the dice. It's not that these events haven't happened before, but it's loading the dice, making it more likely. The extremes are more likely to happen. And what's also more likely to happen is you get more two at once. It's one thing if you're Mozambique, a poor country, and you get hit by the cyclone and it devastates your country. But if you got 10 years to recover, you can kind of get on recovery. But now you get a second cyclone hitting you 6 weeks after the first one. Now you got a poor country. How do you handle that? Look at the Caribbean, some hurricanes we had. So it creates political instability, and that's not good either. So I just picked a few examples here. I won't go into detail of just how things have shifted. You can read it. I didn't realize the Sahara Desert was getting bigger, and Libya was mostly non-desert. Now it's mostly desert. So you've got a country we think about ourselves, the United States is huge. 2 coasts, mountains, plains, rivers, lakes, all kinds of stuff. If you're a small country that just, is now near the Sahara, and it's getting bigger, now what do I do? I can't grow my food, what happens? And the last one, lobsters are moving north. Lobsters used to be fished out of Long Island Sound, Rhode Island, Massachusetts, not anymore. A few, but 10% of what it had been. It's now up to Maine, and now at some point they'll move. I was talking to the lobsterman summer up there, and he looks out. He was a harbor master at one of the harbors, and he loved to be lobstering. But says, to buy a lobster boat and traps, it's hundreds of thousands of dollars. It's like buying a house that you drive in the ocean to work. Will the lobsters be here long enough? Your livelihood depends upon crustaceans that can move. And if they move to cooler water, now what do I do? And it's a change. I'm going to mention a few questions here that I come across a lot, and then we'll take a break for a few minutes. Isn't climate always changing? Gets asked a lot. Well, yes, it is. But as I showed earlier, it changes usually very slowly, and changes for a reason. And the question is not so much what caused it to change a million years ago, what's causing it to change now. And the analogy is, we've had fires by lightning for millions of years, but that doesn't mean that if your house burns down, it's a natural cause. Could be electrical short, could be arson, could be all kinds of stuff. So the question is, what's causing it to change now? And people have looked at all the suspects. There aren't that many things like the sun's output could change. It turns out the sun's output is not getting stronger. If anything, it's getting weaker, or it's flat. It has some cycles, but the trend from 1950s onward is about flat. You can change the atmosphere, and that could be by natural means, volcanoes, other things, or it could be man-made. And you look at all the factors that can change it, and the only factor that explains today's climate change, what the theory says explains it, which is more greenhouse gases. The question is instead, why wouldn't it change? The theory says, put an extra blanket, you'll get warmer. Why would an extra blanket not make it warmer? And how do we know? I mentioned why humans are causing it. And sometimes it's just, we're 7 billion people, and we use more energy. It's nothing bad that we've done, it just is. CO2 necessary for life as a plant food, how can it be a pollutant? A pollutant in this context is a legal term. The EPA had defined a pollutant as something, which makes sense, something which you have a reasonable expectation to harm health or welfare. Sounds about right. Salt is natural, you need salt to live. You get too much salt, you die. Not enough salt, you die also. So most things are in moderation, they work fine. And so the question is, that the Supreme Court decided in the case Massachusetts versus EPA, I think it was, yes, increased greenhouse gases are reasonably expected to change health and welfare, and therefore it's a pollutant in that sense. It's a legal term. Temperature varies a lot every day. What's the big deal about a few degrees? That was Svante Arrhenius' comment, the Swedish Nobel laureate who did the first projection of burning fossil fuels. And well, it turns out it's one thing to talk about temperature up and down. That varies a lot. If you look at the average across the globe, it doesn't change a lot unless you add a lot of heat to it. Kind of like, think about yourself. If you 98.6 is normal body temperature, if you add 1 degree centigrade, it's almost 2 degrees Fahrenheit. Now you're talking 100.6, 100.4 degrees. You're not feeling so good. You're feeling under the weather, a little kind of achy, and you want to lie down. Well, in that sense, so it's not a large degree change. It's an analogy, not a perfect one, but you kind of get the sense that it doesn't take a lot of change for you as an individual to feel bad. And so it turns out it takes a lot of energy to move the needle. Big oceans, 93% of the heat goes in the ocean. Any who try to boil a pot of water for lobsters, I'm sensing a theme here. It takes a long time to boil the water, or for crawfish or anything else you want to boil. So it takes a lot of energy to heat up an ocean, and it's warming, ocean temperature warming. And so we do a lot of fussing about temperature sensors and where they go and where they're located, but, 70% of the surface is the ocean, and that controls a lot. It's also the speed of change. So let me kind of pause here, take a break for a few minutes. Do you have any questions in your travels, talking to neighbors, what you read, something bother you that I didn't hit here that comes to mind?
Well, the challenge, I think, John, overall is what do we do? There is a precedent that I think is interesting to consider, and that is back in the 70s when the ozone layer at Antarctica was thinning, and the cause was determined to be CFCs. The culprit then was determined to be refrigerants, fluorocarbons used in aerosol cans and in refrigeration.
Yep.
That was an easy thing to solve because it didn't cost a lot of money.
Right.
The average consumer was unaffected by the change that occurred, and apparently the change has been very successful because the ozone layer is thickening.
Yep.
And they estimate that maybe in another 40 or 50 years it'll be back to where it once was.
Yep.
So the challenge is, what do we do as a nation? What do we do as an individual that can make an honest impact?
Yep. Good point. I think that is an example that's used. It shows how the international community got together to solve a problem. Global problems require global solutions. No one country can solve these global problems, and so you have to kind of work with other countries to kind of get it done. And there are different views. I think the economics are a good one. The process I followed for go to an authoritative source to separate sort of fact from fiction, opinions from something that has some credibility. I mentioned applied to the science, also the Bible, might look at the Bible. It also applies to the economics. A lot of what I read is not rigorously based. So the belief that dealing with climate change will decimate an economy, well, if you do it in a stupid way, it would. Let's not do it that way then. Let's find a way that's not stupid. I mentioned I have an electric car, and it's a couple years old. It's not for everybody. If I was a traveling salesman driving through West Texas, I wouldn't have one from 2 years ago. But they're getting better every year. Ranges are increasing. Time to recharge is getting less. So there's been a tremendous cost reduction curve. Nigeria is one of the most oil-rich countries in Africa, yet half the country doesn't have electricity. So the fact you might have oil doesn't mean that you have a way of taking care of your population. Renewable energy, the nirvana through most of my adult life, wouldn't it be great if we only had fusion reactors? Not here yet, but to get fusion, we spend billions of dollars in fusion reactors, and God's probably looking down saying, you dummies, I gave you one, it's free. You don't have to worry about building one, it's called the sun. You have to hook up to it. The energy is free. Why not use it? And so there's a lot we could do. In a lot of places, it's not, there's no one solution that works everywhere. There's no panacea. All technologies have their downside. But in terms of the mix, wind and solar solve this particular problem, and the costs have been dropping dramatically, especially China. They view it partly as they were killing a lot of their people. You've seen pictures of the Olympics, people walking around with masks on their faces, and air pollution from burning coal was a big problem for them. So they have a political issue. It's not good, even if you're a communist country, to have a lot of your people dying. So they want to find ways to cut down the air pollution. But they also saw a longer-term strategic benefit. They want to corner the market on renewable energy technology. They want to be the world's supplier to everybody, the supplier to the world of solar panels and efficiency technology. And so business opportunity for those who want to take care of it. So I think there are things that we can do on a government level, at different levels, businesses, but also individuals, and I'll come to that. We'll come back to that. That's the key question. Other questions?
I have a comment. I mean, we have that data you showed us over hundreds and thousands of years, and then the stuff over the decades makes it pretty clear to somebody who's open-minded enough that something's going on. What's harder to do is to convince anybody that what they're doing on a small scale is helping, because it's gonna take a long time again to reverse this problem and to flatten out that curve, right? So how, you know, besides doing something and feeling and knowing in our hearts that it's helping, how do we get the message out, what helps, so that people are convinced
Yeah.
it's not a hopeless situation?
Right, yeah, good question. Hopefully I'll address that. It's coming on a slide here. Fehlauer's idea for that. But you might have better ones than that, so. You want to take a break for a few minutes?
Yeah. Let's gather back about 10 o'clock.
Okay. We'll get started with the rest of this, and then, I mentioned I had some books over there that you may want to glance at. Some are scientific oriented, from academia, from the U.S. government. Some are religious oriented, a variety. There's a lot out there, and I found, you know, them interesting. I've not read them all, I must confess, but I did refer to them, appropriate to a person of management, you know, kind of get the gist of it, kind of details to left to the interested student. Before I start the next part of this, what we do about it, any questions that occur to you on terms of the question about climate change, kind of? Yes, Debbie.
Talk about things we're putting in the soil, that concerns me, because I think I do that. And I don't want to do that, I mean, like pesticides and stuff like that.
Yeah. So there is actually a couple areas for that. One is the, you know, as we grow more food in the land, we put a lot of chemicals for fertilizer, pesticides, herbicides, etc. A lot runs off into the streams, rivers, goes down to Mississippi, creates dead zones in the Gulf of Mexico. There's also, and so that's one area of environmental change. And there's also how we do our farming. There's a book over there, I just came across this in the last few weeks, called Project Drawdown. And what it seems to be doing, they got a bunch of scientists and people from especially different areas to say, what could we do that would reduce the amount of greenhouse gases going into the air? And there's no silver bullet. There's no magic answer. There's nothing, if we only had X, you know, that solves the problem. Even renewable energy, that takes care of maybe a quarter of, I mean, it doesn't change airplanes, doesn't change, you know, how we use our land. Doesn't change a lot of things that might cause greenhouse gases to go up. So they call it silver buckshot, silver bullets. A lot of small things you can do, and look through it. And some were interesting. I have a couple examples here. Most of them are ones I didn't think about. In fact, renewable energy is not the dominant theme there at all. They talk about, and Mel mentioned refrigerants, the chlorofluorocarbons that were causing a hole in the ozone layer. Well, replaced with something else which doesn't affect the ozone layer, but affects climate change. I call it HFCs, I guess. And so we have to, so the amount of refrigerants we have, the chemical that's used for that, can cause a lot of damage to the environment, to the global warming also. And so awareness is one of the things to consider here. So, but land use, there's a cousin who got into this from a different perspective. He does some ranching, had done some ranching in Mexico, northeastern Mexico, where it's fairly dry. We visited him one day. I visited him a couple years ago, 3 years ago now, and we were there for 3 days. And 2.5 days, he talked about water. You know, kind of how little they had. He was in the water commission, how the reservoir, which was mostly empty, you know, how you let the water out and what the process is, and running down the channels, and how many turns you make on a little valve to let the water flow down, and for how long, and very structured, regimented way. And you have to get agreements with the downstream partners on who uses the water, and some are ranchers, some are state of New Mexico, some are national parks. And the worst, they said, what we gotta make sure we never do is let any of the water end up in Texas. I sense a little rivalry there. But he was concerned about how you till the ground. Some takes more moisture than other things. Warmer air evaporates the ground faster. So one reason why you should expect to get more droughts. Droughts occur in dry areas, doesn't get enough rain. Well, if you have higher temperatures, you get more evaporation. So it takes whatever drought was going to occur anyway, makes it maybe longer, more intense. Some parts of the country get a lot of rain. And more moisture in the air, get more water coming down. So, climate change didn't cause Hurricane Harvey, but it seemed to stall. We're seeing more hurricanes kind of get stalled out, and it starts this conveyor belt of moisture coming from the ocean, from the Gulf, or from the Atlantic, through the hurricane onto the ground. Nobody is designed to handle 50 inches of rain. There's just an unimaginable amount hitting one spot. So how we use the ground has an influence on that. And some of the Project Drawdown talks about farming techniques that we use that might be less water intensive, might cause less decomposition of plants that add to this problem. So let me go through some answers. This is now, I'm shifting from things that have a solid scientific foundation to Fehlauer's opinions. And this is my thoughts here. You can have different thoughts. So I think there is a role for industry and for government. What the roles are, what level of government, that's a challenge. Some terms get used a lot. Mitigation is one term. Mitigation means don't put the greenhouse gases up in the first place. That seems to be the best approach. Do something. So burning fossil fuels will be fine if you could keep the CO2 or the methane from going up in the atmosphere, and you knew where to put it. We don't have a way of doing that right now. People are looking at it. It's called carbon capture and sequestration, CCS. And the same, you look at the big oil companies, BP or ExxonMobil, they've got technology that knows how to put deep holes into geological structures that have attributes they like for extracting oil. They have the technology to also find places to put CO2 that might come out of the air, if we knew how to get out of the air, which we don't right now. Renewable energy obviously is one that's mitigation, so harnessing the power of the sun or the wind. It's true the sun doesn't always shine where you are, the wind doesn't always blow where you are, but it's often shining someplace, and the wind's often blowing someplace. And they talk about the smart grid, just having longer transmission lines that carry the power from maybe Nebraska down to Texas or Texas to Alabama. That can do a lot to smooth out peaks and valleys. The cost of renewables has been coming down a lot. I was reading Florida Power and Light had planned on building a gas-fired plant to handle short-term demand peaks, and they found it more economic now to put in solar panels and batteries. There are other storage technologies besides batteries. There are hydroelectric or hydrological, I should say, solutions. You have a reservoir with a dam that can be powered by electricity with turbines. You pump water in the reservoir when the sun's shining, and now you've stored energy there, and it can flow through the turbines and create. Depends where you live. Not every technique works. If you're in the flat country, not a whole lot of dam possibilities. But there's things that can reduce or stop that. I think there are marketplace incentives that could incent moving in one direction and disincent the other direction. There are, I'll mention sort of a proposal that has support across the political spectrum. So I still won't get into politics. Has support across the political spectrum, but it's not a slam dunk. And the people who oppose it, it's called a carbon fee or carbon tax. And the theory is it's a time-honored tradition. If a business is causing a pollution problem, they should pay for cleaning it up. So if you have a business moves in next door to you, they start dumping trash in your backyard, you say, no, I don't like that. well, I gotta put it someplace. Well, if you're gonna put it there, then pay for hauling it away, or something like that. The basic principle has been around for hundreds of years. And this will just apply that same technique to, now that we know that this is a pollutant that's causing problems, just have them pay for it. Devil's in the details, and there are good ways of doing it and bad ways of doing that. But you hear about carbon fee, carbon tax, it has broad political support, but there are also ways of doing it poorly, and it's not, once you say the word tax, you know, that's a death knell. Last fall, I had a chance to visit, one of the books here is by Mitch Hescox and somebody else. Mitch is a son of coal miners in Pennsylvania, conservative minister. And he was here at a local church with Bob Inglis. Bob Inglis is a former congressman from South Carolina who was on the House Science Committee, and his son, his senior son, challenged him to take climate change seriously. And he, being a congressman on the Science Committee, got to go to Antarctica and the Great Reef of Australia and saw the effects of climate change, talked to scientists, and came back and used the word tax and got primaried by Trey Gowdy. And people say, whoa, I'm not going to do that. And it became a perception, and let's not do that. I think that the tide is changing now. He was very open about, you know, he did a face plant on that. He had a good idea, but he got ahead of his headlights on how to approach that. And so, you know, people are messy things, right? Politics, and I'm not a politician. Don't want to be one. Wouldn't be good at it. But somebody's got to do it, and I'd say we need to talk to them about it. So mitigation, stop it in the first place. Second is adaptation. You know, those of you who saw the hurricane that hit Panhandle, Florida, saw a picture of devastation. I think it was Mexico Beach, one of the towns. Everything's leveled except for one house is standing. What's that about? You talk to the owner, and they're from, I think, from Tennessee or Kentucky, and they built to a higher building standard than was required. And they had simple things, added a little bit to the cost of the house, but not a lot, but made it, you know, they had bolts to attach the roof to the walls, and ways of, into the foundation, and just different ways of making the structure more physically sound, and it withstood the hurricane. Others didn't have the building code, so you can change the building code. It's not a big deal. Now, retrofitting one is obviously a big deal, but once a hurricane comes through and knocks down neighborhoods, if you're going to rebuild, it may as well rebuild with something stronger. It's adaptation. There's other kinds of all kinds of ways of adapting that make sense in different parts of the world, different parts of the country. But finding out what the best practices are. I joined a small, it's a small group in Maine called A Climate to Thrive. It's neighbors helping neighbors. It's a nonprofit, and they're basically just sharing ideas. I mentioned I didn't think solar panels would work in Maine. I had no idea why. It wasn't done. I didn't see any house that had it, but then somebody said, "Well, I've done it. Really? What it cost?" And so he showed me the economics, and it made sense. It paid off, and so we had them installed, and it's great. Electric cars, I mentioned that. You know, a lot of times it's just, you know, I've never done it before, might be true, but that's not a reason to not do it. Or we've always done it this way, might be true, but that's not a reason to change it. So a lot of it becomes cultural inertia, and a lot is, you know, if there was a place to say, hey, I've tried this, it works, this is great. You might have ideas that you've tried stuff and you just haven't thought about. That's I call best practices. And we will pay a lot of money, we have paid a lot of money for adapting. Are these all projects good? Venice is putting up a barrier because you can't change the sea level, and there's a lot of flooding in Venice. Partly it's ground sinking, partly ocean levels rising, but they were about storm surge coming in. But you also have to, so a levee is not going to work. Besides being expensive, they want ships to come through, so you have to have a way to let that happen. So we're doing something similar, a proposal called the Ike Dike. Have you heard of the Ike Dike? Hurricane Ike hitting Galveston Harbor caused a lot of damage, and Hurricane Harvey did also. And there's a proposal to build something similar to protect Galveston Harbor. A lot of refineries, a lot of chemical plants, a lot of city, and $30 billion. Will it work? I don't know. If it does work, how long? So somebody's out that, you can tell once, if it's your land, if it's your, you know, especially if you, like me, grew up on a farm, you get a lot of times you get a strong association of where you grew up, where your dad farmed, where your grandfather farmed. And so you want to protect it. You don't want to just say, well, it's cheap for you to move. Well, yeah, but it's not an economic issue, it's an emotional issue. And so sometimes it's cultural. Charleston, South Carolina, beautiful city, tremendous history. It floods now often at high tides. It's going to get worse. So do you start raising the city up? That's kind of expensive. You know, at what point to say enough? So a lot of these are tough battles. There's no simple answer. In my opinion, a lot of these local governments might go after it. San Antonio has a climate plan. I've not read it, but so they had some meetings about it. The states can do some things. Some states are taking action to try to help mitigate this. Industries more and more are moving for a variety of, sometimes it's good business. They want to invest. I mentioned China is investing a lot in renewable energy, technology. You know, a few years ago, you went to Home Depot to buy a light bulb, and you find incandescent light bulbs, some fluorescent ones, and maybe an occasional odd-shaped thing called an LED light. Now they're mostly LEDs. They're great. They don't burn out, take very little power. So a lot of these are you know, industry can do stuff to make, if a product's available, most people don't really care how it works. People don't even know how it works. It's just, I want light, I want power, I want a car to work. And so the industry can help doing that. More and more pension plans. The head of a UK set of funds, they control £1 trillion of assets, go to the various companies they have stock in and say, what's your plan to deal with climate change? I just saw two large shareholders in ExxonMobil are not going to vote for some of the directors on the board because they don't think they've been credible or open or forthright or whatever, or not complete enough on their plans for climate change. So you hear that more and more happening. So industry is taking effects. I think there's a role for negotiating with other countries. I don't think it's a good idea for each state, each city to try to do it on their own. I think countries need to negotiate. And these are tough negotiations. You know, what's fair? I always hate those questions. If you were in management, and so I would say, but it's not fair to do X. I hated them because what's fair for A is not fair to B, and you can't. It's never fair. Or if you have kids, you know, same thing. It's not fair. So negotiation among countries will be a challenge, and we have evidence where it's worked, but we have a lot of evidence where it hasn't worked. I mentioned the Kyoto Protocol and the Paris Accord, two examples where it doesn't look like it's working a lot well, but it seems to be a necessary step. And I personally would like to have a source of honest information at all levels. You know, I was going through here, I could easily find information on the science, easily read biblical messages. Trying to find out what they do about it, it was a lot harder. You know, it wasn't obvious. You get these bits and pieces, and maybe I'm not looking at the right places, I don't know, but it'd be nice for me personally. I'd like to be able to go to a website and say, here's the things you can do.
May I make a comment on that?
Yes, sir.
John, how do we avoid unintended consequences? Going back to the CFC solution?
Yep.
I've recently migrated to battery-powered lawnmower, weed eater, and blower, and I love them.
Hmm?
But I'm worried about the impact of the proliferation of lithium-ion batteries and whether or not that technology is going to be
Yep.
a detriment or a bonus.
Yep. Good
Take
question.
down airplanes.
Pardon me?
I said they take down airplanes.
That's right. Well, if they catch on fire. Yeah, the lithium battery is a wide range of different kinds of lithium for different, the ones that go in the computers have had some problems with those on airplanes. That's a good question. I don't have an answer for that.
Well, I just want to make a comment on this as well. So battery, going back to your analogy for light bulbs, right? So a battery pack and the technology within it that actually powers the battery, the form factor can stay the same. You can change what's the inside. So I think the benefit is that it centralizes the point where those batteries are manufactured. It centralizes where you can actually do something at that point and then distribute the quote interface, if you will, doesn't change. So here's your new battery. It doesn't have lithium ion on it. It works great or is better or the same as the old one. You pop it in, you're good to go. You do your yard.
Right.
So
Yeah, there are, being a double E, I pay a little more attention to these. I can't pronounce this. There's a name, begins with a P, of a different technology that would get more power density than the current lithium-ion batteries. All technology has some kind of downside. We use a lot of things called rare earth elements. Rare earth elements are very common, but they're rare to find them in a pure form, and it takes a lot of processing to get them into a form, neodymium, ytterbium, stuff that you just never heard of before, scandium. We've outsourced. They often cause pollution when you mine these, refine them. We outsource that pollution to China, where they do a lot for us. So even though our emissions go down, is that because we did something good, or did we just say, there's some of the problems, we'll let you guys handle that someplace else? And I don't know. I don't know the answers to that question.
I guess if I could finish that thought, the
Yes.
battery, is that
Yes.
at least you're not bound to something that's dependent upon burning something.
Yes. Yeah, so again, I'm a believer that all the unintended consequences, we ought to go eyes wide open. There is a lot of pollution from mining coal and burning coal ash, and how do you handle that? Well, I think the ways you can handle it, if you don't try, then it gets worse, obviously. I think one reason why China has lower cost in a lot of areas is that they do a lousy job on environmental issues, in my humble opinion. I could be wrong. I think they might be getting better, but nuclear power is got its advantages. It's not been economic, and what do you do with this stuff after you've used it? Hydrogen power could be great. You could use, if you use electricity for desalination plants, or for creating hydrogen by some technique. It could be burn hydrogen in a car versus battery power. All these could be good things. I think government, some of these are higher risk technologies, and I think, to me personally, I'd be okay with the government investing. Well, you can invest in the stock market. You can invest in a tried and true big company that prices don't change too much. AT&T. It does go down, but it doesn't go up too much. Or you can invest in smaller companies where it's higher risk, higher reward. So the same thing with technology. I think the government could play a role there. How big? That's a political question. But I think that could be helpful. So I think one thing I liked is an expression from engineering world. Charles Kettering did some inventions with spark ignition systems in car engines. A problem well defined is probably half solved. Meaning that if you're not quite sure what the problem is, well, you're not going to be really good at solving it. If you have a very crisp, clear definition of the problem, we're really good at doing that kind of stuff. A personal example, 9/11. Driving to work one morning and I hear about an airplane hitting World Trade Center. What's that about? Tuesday in 2001. By Wednesday, Colin Powell had called up the CEOs of various communication companies, including AT&T, saying we've got to get the stock exchanges up by next Monday. I got the assignment for AT&T to coordinate the AT&T efforts. We had an office at the base of the World Trade Center that got demolished. Cables got disrupted, cell towers fell down. Well, what that means, stock exchanges. Who are they? Who do I call and ask what do you need? Nobody's working, it's all closed. But we had a well-defined problem. Monday, stock exchanges, up. I wasn't saying, as long as it fits in your schedule, or as long as you fill out the paperwork okay, or, it's Monday. stock exchanges, period. Everybody got the message. Vendors, regulators, government officials, a well-defined problem, and we got up and running by Monday. That's not the normal. You don't want to have that kind of disaster to kind of befall, but humans are very good at crystallizing, rallying around a very specific problem. Geological things are slow moving. You can see a hurricane, you see the Bayou Navy that goes out, and they're fantastic at risking life and limb to rescue people after a natural disaster. You see it with fire people, first responders all the time. Something that's kind of slow moving, I don't recall what last week's weather was like. I certainly don't recall what it was in 1990. This is kind of a slow moving kind of, it doesn't have the same, you don't get the same adrenaline rush. A tiger jumps out at you, caveman Og, you kind of respond right away. You don't get an adrenaline kind of rush with the charts I showed. Maybe my sparkling personality got you a little pumped up. It's like, you're not going to say, yeah, I'm going to go out here and just, that creates another set of issues. So what can I do? I think getting informed, and this is part of that informing. Again, don't view me as the expert. I'm sharing what I've found, and I welcome you to go test it and look up stuff. I have some pages of some references I've used. There are lots of other ones. If you find out something different or something new, I'm welcome to hear from you about that. I'd say as political leaders of any party, doesn't matter, Republican, Democrat, green, red, blue, pick whatever party you want to support. Just say, take it seriously. Don't say it's a hoax. Take it seriously. Do something about it. Business leaders, same kind of thing. Take it seriously. Church leaders, what should churches be doing about this? One of the books here talks about just a collection of stories from different churches my son-in-law gave me, things they've done of creation care. Some are climate change related, some are different. But there's some stories about what churches have done, and they found, I saw it on Twitter this past week, a small little church in West Virginia that, like 10 members or something, but they put solar panels on the roof for their community. A lot of times people can't or don't want to put solar panels on their own house roof. Maybe they got trees, not so much here in Texas where they're not that tall, but other places where you might want shade, or you might have HOA rules, or you just don't like the look. And so they have, electric companies don't care. It varies from state to state, but up in Maine as well, you can be part of a community solar, put it on a landfill that you can't build anything on anyway, and you own a piece of that, and all the electric company cares about is Fehlauer has so many kilowatt hours of solar panels. It's the same, it's an accounting issue for them, and I get credit for that. I'm not doing that, but my neighbors do that. There's a lot of things that can be done, and sometimes on top of a roof of a building works that way. Talk to neighbors about it. Just take the issue seriously. Some things you can do where you live, I just picked a few examples. Make your home more energy efficient. Mike Barton, who comes to church occasionally, he just had his air conditioner died and replaced it with a new one that's more energy efficient than the old one. While the old one's working, maybe it's not worth doing, but at some point you want to replace it. Well, pick one that is very energy efficient. Turn off your, do an energy audit. One thing I didn't realize, that somebody had done a study, the number of things in your house that draw power, I think they call it power vampires or something, sucking power. I leave my cell phone charger plugged in all the time. It takes power. Linda's saying, no, don't do that. One of the biggest users I realized was the DVR. It takes a lot of power. It takes about as much, whether it's on or off, it takes about the same amount of power. Because they're sitting there listening for, downloading new schedules, information. It takes a lot of power. I'm not sure I recommend turning it off at night, but you go around the house, what takes the energy in my house, and do I need that there? And I probably should do a better job myself, not keeping cell phone chargers plugged in when I'm not charging anything. So making your house more energy efficient saves money. Whether you agree with climate change or not, that's a good thing to do. Up in colder climates, our church in Maine does something where some houses aren't insulated well, and we have these, get a wooden frame measured for a window with a plastic, shrink wrap insert, and you just press them in for the winter time, and it's like a thermal insulation barrier, and it saves energy for the homeowner, or you get more insulation, so you use less energy. Waste less food. I grew up the child of immigrants who went through 2 depressions. I didn't realize that you were allowed to leave food on your plate. I thought it was against the law. On your plate, you eat it, son. That was it. Went to college, I had a roommate who didn't eat everything. I said, wow, I didn't know that. Jesus fed the 5,000. The disciples went out after the meal was done. They didn't say, and threw the trash away. They collected it up. They saved it. They had more, how much bread and fish were left over. They just didn't let it go to waste. And I gotta admit, we waste a lot of stuff. We're a consumer society that just tosses stuff out. It's broken, it's cheaper to buy a new one, it's not easy to repair, whatever. We waste stuff. Moving to a more plant-rich diet. This was in that book, Project Drawdown. I'm not, I like meat, I like beef, but I probably eat more than I need to. And so if I have a choice of, eating a salad with beef or without, I'm more likely to now say, I can pass on the beef now. So there's, is that a big deal? I don't know. But that was mentioned in the book as something to think about. Certainly cows, beef cattle, take a lot of money and room and feed to grow versus the plant. You eat the plant directly, or you let the animal eat it first and you eat the animal. It's kind of I'm thinking about that. I mentioned alternate energies for home and vehicle. They're getting practical. So if you have a chance to drive an electric car, they're fun. I used to have a Roadrunner when I was in college. 335 horsepower, 4 on the floor. It was awesome. I loved it. Then we got married, we had a family. It was quite exactly, we had a station wagon. I got this car, and you put the foot, you can't call it a gas pedal, you put your foot down on the accelerator and just push you back in the seat. I want to blow cars off at the red light, not that I recommend that. It can be done. Because DC motors have maximum torque at 0 RPM. They're just great, they're fun to drive. They're economical, and it's just quiet. I can have a phone conversation in the car without a lot of road noise. Less lawn, more trees. Apparently the biggest agricultural crop we have are lawns. Most area, most water, lawns. They look pretty, and we have a good size one. We have a corner lot, and I got to mow it. But every time we do landscaping, I say make the lawn a little smaller, make the flower bed a little bigger. Something that doesn't take as much water. I spend money. We're up in Maine, and I'm spending money here in Texas putting water on my lawn so it goes through the limestone and disappear. That's not the smartest thing for me to do. Plant more trees. I mentioned briefly, I've not looked at this, but apparently a bunch of African nations are concerned about the Sahara coming down, and they want to plant a band of trees. Other countries have, apparently youth in Canada, it's a national service project, go out and plant trees. So I'm thinking, we have fewer trees now than, I think I read something like average of 2 trees a day per person get cut down. It's a good thing to have. And come join me on the journey. But I'm only one person. What can I do? There's an Israeli poet who just died this past year. I like this quote. The fire is very large, and they only have a teaspoon. But there are millions of us, maybe billions, and we all have teaspoons. And he sort of, there's an organization in Fehlauer, Sweden, has little teaspoon lapel pins that I say, I can't do a lot, but there are a lot of us. If we get together, we can make a difference. So the key takeaways here, from my perspective, are we have already changed God's creation design. It's unintentional, but now we know it's changed. Mel had asked a question when I had discussed this with him before this talk. What's the optimum temperature to have, Fehlauer? If you don't like where we're headed, what's better? Well, most scientists would have said, we're not smart enough to have an optimum. We don't know what it is. We probably go with whatever we had before. We're not smart to say a different one is better. You turn the question around. If you were a politician running for office, and your platform was, I think we ought to have a different climate. I think we ought to have a warmer climate. You probably wouldn't vote for that person. You wouldn't be saying, I think that's a good idea. I like that. Because you do some research and say that's kind of a dumb idea. Well, we're kind of unintentionally doing the same thing. We've changed it. So now the question is, we do have a question to answer. What is it? Where do we stop? And so we see the pain of changes now, perhaps. I don't think the pain is as much as people say it is, because I hear numbers being bandied about that don't seem to make, there's no basis for them. But certainly it can be painful if you are a fossil fuel company. If you're Peabody Coal and your job is mining coal, and somebody says, I don't think we ought to be mining a lot of coal, well, that's a problem for your business plan. Now, some energy companies have been diversifying. Saw a commercial about BP last night about how they have gas, but they also connecting with wind energy. And so I think there are opportunities for fossil fuel companies to diversify. No different than, this is capitalism at work, no different than happened when the businesses that did whaling to get whale oil kind of got put out of business by oil. Or the horse and buggy manufacturers got put out of business by the cars. Cars weren't practical at first, but they over time got more practical. And so it's inevitable that the incumbent technology wants to fight for its life. It holds on. It often has political power, economic power. The new one is not as good, but it's coming. And it's hard to beat free. Something like 1.6, 1.7 trillion barrels of known oil reserves. 1.7 trillion barrels. $60 a barrel, that's about $100 trillion worth of assets. And here's Fehlauer saying, I think we ought to keep it in the ground. $100 trillion, Fehlauer, I'm thinking, there's a lot of power there behind that. And I can't fault them. I mean, the officers of a corporation, board of directors have a fiduciary responsibility to look after shareholders' interests. And near term, use what assets you have. And that's the way we're built. So at some point, there's got to be a way of saying, but longer term, that may not be the best. How do we balance this two? I don't know, but that's the challenge in front of us. It is causing serious, I know there's been pictures in the past of the poor polar bear, the poor penguin, and it's true that animals are suffering. If you're human beings and it's too hot in Central America, you can go north. If at some point the U.S. gets too hot, we go across the border to Canada, as long as they don't put something to block us. But we're the animals who can't go any farther, or they live in high mountain elevations, and they go higher in elevation. Lobsters can still go someplace, but some animals can't, and they go extinct. A lot of reasons why species go extinct. Climate change isn't the only one, but it's putting stress on them. Great coral reef, as the ocean rises in temperature, as the ocean gets more acidic, coral gets stressed and it dies. Coral bleaching. There's a lot of species of the ocean around coral reefs, and they're in danger. Can you say any one particular species will go extinct? Can they adapt? If it goes slow enough, they can adapt, it might change somehow. But if it happens too fast, they'll have trouble adapting. And there can be some cliff effects. They call them tipping points. There can be some things that we don't know about, that we've crossed a line and something will happen we can't recover from. At the moment, scientists are saying we don't know of any right now, except it looks like we might have missed a ice age. I showed the temperature curve going down. That's from slight changes in the orbital mechanics of the Earth. It goes every 50,000 years or so. Temperature is going down. We could have been heading for one. Maybe it was a good thing. We did intentionally. We kind of missed the ditch of Ice Age, went to the other ditch of Tier 1. We gotta find how to drive down the road here, between the two. There was an article in Nature magazine. Nature is the premier general science magazine, peer-reviewed, out of the UK, the Royal Society in England. Science is the premier magazine out of the American Association for the Advancement of Science. Both are general interest. I've gone to our libraries, I don't see them there, so you have to find a library that has them, or subscribe to them. But there's an article in Nature this past week about the permafrost. Scientists thought they figured out it will take centuries for the permafrost to melt. There's twice as much CO2 stored in permafrost than we have in the atmosphere right now. If it all melted really fast, that's a problem. You know, so that curve might be going up for things other than humans, might be going from melting of permafrost or things like that. But they say, you know, your assumption about centuries may not be right, because it's melting faster and in different ways. It's hillsides are washing away because permafrost melts. You've seen about Native American First Nation people in Alaska who their towns are sinking because they build on permafrost, which isn't so permanent anymore. It's temperafrost. So the sooner we act, the better. Many solutions are available today, not all of them. There's no panacea, and the transportation, the airplanes, there are some experiments with electric-powered or hybrid airplanes, but they're not, you know, a 777 kind of level yet. You know, you go to Europe or China, Japan, you have high-speed rail lines, and they're very, our daughter uses it all the time in Europe to get around. They're very efficient, they're fantastic. We don't have them here in America. It'd take a long time to get them. Maybe we should work on that, don't know. I commuted from San Antonio to AT&T headquarters in Dallas for a while, get in the long line at the airport, get the 6 a.m. flight, have breakfast up there, have a full day of work, come back, have dinner at home. I would have rather taken the train if one existed, but it didn't. So, nice to say, you know, train's a good alternative, but it takes a while to get one. But a lot of these things are good whether you believe or accept climate change or not. The science doesn't care. You know, God's creation says the same laws of physics will apply everywhere, whether you're a Republican, Democrat, you're old or young, you're from America, you're from wherever. The same laws apply. Ice melts at 32 degrees Fahrenheit pretty much everywhere. The book I have there on planetary climate is called Planetary Climate. Carl Sagan is one that you might have heard of from Cosmos fame. He got turned on to climate change on Earth by looking at Venus. You know, he predicted that Venus's atmosphere was causing the planet to be so warm. It wasn't that it was closer to the sun. In fact, he said it should have been cooler. All that white cloud stuff should be reflecting sunlight, so there shouldn't be a whole lot of, yet it's hot enough to melt lead. And so he surmised it must be the atmosphere holding heat in its greenhouse gases, and when he sent probes up there, he was right. So based on that, he came back and got turned on to climate change here on Earth. It's the same laws of physics. The details are different, but the same laws apply. If you go to YouTube and look up Carl Sagan and climate change, he gave a talk in about 1990, 1992, talking about how real, he could have given the same talk. And we have a political problem because we're not making any progress on this. He related back to the myth about Cassandra, I think it was. Looking for liberal arts majors here who call these Greek myths. Linda Swanson, looking at you. The Cassandra apparently was, in Greek mythology, was a very attractive lady. Apollo, whoever the god was in charge, wanted to make her his wife. She said, not so fast, what are you going to give me first? And what do you want? Well, how about you make me a prophet? I can predict the future. He says, okay, you got it. And gave her the ability to predict the future. He said, okay, now I got that, I don't think I'm interested in you. See ya. Well, he got angry. Apparently, he said, apparently the rules of gods back then, you couldn't take it back. So, well, he just said, I can lay another one on you. Nobody will believe you. You can predict the future, and nobody will believe you. And that was Carl Sagan's comment. What if scientists could predict the future, but nobody believes them? kind of what's the kind of the challenge here. Caring for God's creation is an expression of our love for God and our neighbor. It's also our responsibility. And that's it. Yes.
In your references and your studies, did you find any scientists or authors that totally disagreed with each other, blatant opposite
Well,
opinions?
having,
This is black, this is white, no, it's not.
I mentioned the culture of the scientists. Scientists love to argue, and there's nothing better than you can prove somebody else wrong. They're incented to want to find why what you said was wrong. So the first skeptic in climate science is the author himself. He says, I know I'm going to get a lot of people arguing with me if I say it's wrong, but I'll get fired if all I do is repeat somebody else's study. So what scientists try to do is find something new that's defensible. So they're incented, you'd win a Nobel Prize if you could prove what I said was wrong. So riches will be showered upon you by the scientific community, by fossil fuel companies. So the debate now is not over anything I said. The details, is it statistically significant that the hurricanes were more, you get debates about that kind of stuff going on. Somebody says, I think the climate was causing this to change. No, I don't think it might have, but it's too soon to tell. You get those kind of debates, and time will tell whether it's true or not. In terms of people who, you've heard of 97% consensus. Not that consensus is a mandate, it's more an observation. A lot of ways you can measure it, but basically, people who don't agree with what I said, there's no common theme there. Some say it's not happening at all, some say it's the sun, some say it's some planets, planetary movement, it's gamma rays, it's all kinds of, there's no particular other side. There are many people saying, I don't like your answer, but there's nobody debating what I've said here. Predict the future, make predictions is hard, especially about the future. Wasn't that Yuki Berra said that? Making predictions is hard, especially about the future. And so the biggest unknown about the future climate is not the science, is what we're going to do about it. And so the question is, how fast can we turn the curve? And so with the science, the IPCC, for example, the next round is coming up, they call it representative concentration pathways. It must sound better in French, I don't know. But they said, look, let's look at different things that could happen. I'm not sure what humans will do, but at one end, they'll work very aggressively to stop adding greenhouse gases. At the other end, business as usual. They'll probably pick someplace in between, we just don't know where. So we'll have a few examples, and you decide where you want to be on that curve. That's the biggest unknown about the future changes. There are unknowns about things like how quickly does ice melt, and people just aren't really good at predicting. So a lot of times, how much will the sea level rise by 2100? Well, 3 feet, 6 feet, 2 feet. It's more a question of if it's probably be in the multiple feet. Will happen in 2100 or 2150? Does it matter? The fact it's rising. From my perspective, it doesn't matter when it occurs, but the fact that the world my kids are inheriting will be different than what I grew up in, and that's, to me personally, is sad. So, other questions?
Just an observation, John, it's a shame that this subject has been weaponized by politicians because it tends to block the legitimate debate and understanding.
Yeah, it's unfortunate. I followed a lot of debates, follow a lot of the sociologists study this issue. Why do people believe what they believe? Whether it's climate change, other areas, flat Earth. I went to a conference in Austin a couple years ago, this American Association for Advancement of Science. One of the ladies I followed, Catherine Hayhoe from Texas Tech, she gave a plenary talk there right before Joe Biden gave a talk also. So it's a world-class kind of forum. I went to sessions where the sociologists did studies of why people believe what they believe. And it has been weaponized. As I mentioned, I'm, like each of you, I've got political opinions on subject A, subject B. We might agree on one, different on another. I don't like the labels because they tend to have, well, if you say you're X and this, you believe the following 5 things, which, well, that's not me at all. But the number one thing that determined what people believed was their political beliefs in America. Other countries aren't like that, but in America that's the number one, and which is unfortunate. So, there are solutions that are very libertarian, very conservative, very Democrat-oriented. They're all over the map. And I said, pick one. It doesn't matter to me which one. You know, in life, if you want a certain result, there's 2 outcomes. You have the result you wanted, or you have an excuse. Creative excuse, lame excuse, new excuse, old excuse, lengthy, short. They're all adjectives for the word excuse why you didn't do what you wanted to do. And it doesn't matter to me who gets credit for it or what party comes from. Let's work together and fix the problem. And again, let's not pick the ones that are stupid, that crater the economy, that do that. That's a false dichotomy. Either you do business as usual or you ruin the economy. Well, that's not the choice I see. There's a lot we can do that's fixing this problem without causing great harm to the economy. And I think we as Christians are obligated to go find those solutions. You know, when the time comes that the king asks, are you a goat or a sheep? What did you do for the least of me? I want to say, well, I've tried. And this is my first step at doing that. And I thank you for taking the time to join me in the journey.
Thank you.